All right, next we have example 4. Okay, this is the last example that we will see from this lesson. And then after this, we will work with some homework questions. I'll put some videos that deals with homework questions. Example 4 has to do with graphing the original function f if you're given the graph of the derivative f prime of x, okay, or f prime in this case. On the right-hand side, you have a graph of the f prime of x. And then based on this information and based on a couple other things that you're given, can you figure out, can you sketch the original function without any ambiguity? Well, let's see. We shall see. We shall see if you have enough information for that or not. We know that we're given that f prime of 0 equals 0. So at least for x equals 0, my original function had a y value of 0. Okay, so that keep that in mind. Okay. As for, let's see, the graph of the f prime is shown on right, figure 3.4. So we have that on the right side. And then we also have to use the fact that f is continuous for all x. So no removable discontinuity or no jump discontinuity for this case, nor does it have any infinite discontinuity. So we'll see about that. Okay. So it's when x equals 0, y equals 0. When x equals 0, your slope appears to be, let's write that out too. Your f prime of 0 appears to be negative 1. Okay, it's just, okay, maybe I shouldn't confuse you. It's just that point right there. Okay, we have the graph of the derivative. When x equals 0, your y value is negative 1. So what that means is your slope of the original function must have been negative 1. Okay, when x is negative 1 for the derivative, your y value is still negative 1. And then same thing applies for negative 2 and negative 3 and so on. So when x is negative 1, at least your f prime of x should be negative 1 again. And then when x equals negative 2, same thing happen again. When x equals negative 3, same thing happen again. Okay, so but if you look at positive 1, when x is positive 1, you don't have a derivative there because your left slope, the left limit is different than the right limit. So at 1, you could say it's undefined, okay, or not. It's, you could say for now, no derivative at x equals 1. But as soon as you get to something that's to the right side of 1, like 1.1 or 1.2 or 1.01, your derivative value becomes 2. So when x equals 2, your f prime of 2 would be 2, f prime of 3 will be 2. When x equals 4, 5, 6, doesn't matter. It will still be 2. Your slope will be 2. So using this information, well, let's see what happens. Okay, so when x equals 0, your y is 0. So that's your starting point for the original function. And then at 0, when x equals 0, you have a slope of negative 1. Okay, slope of negative 1. What that means is you go down 1 and then over 1. Okay, or you could go up 1 and then left 1. So you have a slope of negative 1. And then at negative 1, when x equals negative 1, you have a slope of negative 1 again. When x equals negative 2, you have a slope of negative 1 again. So it looks like there's this continuity. Okay, when x equals negative 3, your slope is negative 1. So your resulting point is over here. So now take a look at this. Okay, so what you end up with is a line on the left-hand side. And this will continue. It will continue until when x equals 1. Something happens at x equals 1. Okay, we'll see. Okay, to the right side of 1. Okay, to the right side of 1, your slope appears to be 2, immediately following 1. And the fact that this is continuous, we're told that the third condition in here, the original function f, we're graphing f of x by the way, is continuous. So you resume graphing this at 1 and negative 1, that point right there that we just finished with. At that point, your slope now changes to 2. Okay, anything to the right side of positive 1, your slope is 2, x is positive 1, but your slope happens to be 2. That means your rise is 2 and run is 1. And rise is 2, run is 1. So you end up with a steeper line on the right side. So you end up with something that almost resembles an absolute value function, but okay, this officially speaking, this is a piecewise defined function where you have two equations, two separate equations. On the left-hand side, your equation should be y equals negative x. On the right-hand side, your equation appears to be, what is it? I know that the slope is 2, so y equals 2x plus negative 3. X, your slope is positive 2, and then y is equal to x, and then it passes through 1 and negative 1, so it's minus 3 right there. Yeah, so it's a piecewise defined function with those two lines. Okay, again, the reason why the derivative is not defined at x equals 1 is because at that point, because the simply derivative doesn't exist. Okay, derivative has to do with the slope of the tangent line, and that slope of the tangent line has to do with what the slope is approaching from the left side and the right side as well, but it's approaching to a different value from the right side as it is from the left side. So it's not defined, the derivative is not defined at x equals 1.